Hello everyone, welcome to the ELE channel. Today's topic is how to select the equations that we have derived in the kinematics. Now, this is the most common problem I have seen with the students, that they tend to have difficulty in selecting the equations. Now, there is a very easy way to identify which equation is applicable in what problem. So today, we're going to learn that. First, let's begin with how to select the equation. Remember, we have derived 4 individual equations from that they were dependent on each other except for one quantity. Now, selecting equation is really dependent on the problem. Now, that is why it is important to read the problem and analyze it as much as you can. We'll see that in the next steps. Let's begin with the required step in selecting equation. Now I have separated 4 different steps in order to make this easier. Step 1. Read the problem carefully. Now this part is the most essential part in solving any problem. Reading the problem carefully will provide you the idea that what actually the person is asking you to find. Step 2. Draw a simple diagram of the problem. Here we call that diagram as a free body diagram. So free body diagram is the most important diagram. You don't have to be very technical about drawing. It can be a cartoonish drawing, but the drawing should be sufficient enough to give you the idea that what is going on with the problem without even reading the statement. So this kind of step will emphasize on problem solving without actually reading the statement. So when you go back to the problem or you forgot something to mention in the problem, you can just review the diagram, and that should give you the idea of what was the problem asking and what were you looking for. Step 3. Write down every given quantities. Now I know that this is a extra step, but it is the most essential step. Now given quantities are the most important thing. So when you are solving the problem, it is very essential to write what is given to you and what you are looking for. So that goes on the step 4. Next, we are learning about the kinematics equation. Now remember, we derived the 4 different equations. Now let's review them furthermore. So the most general equation was that x equals to x naught plus v average times t. Now v average is v plus v naught divided by 2. This one is because we had a constant acceleration. With a constant acceleration, the velocity is going to keep on increasing. So the average velocity will be somewhere in the middle of final velocity and the initial velocity. So these two are the most general equation that other equation came from. So let's review those other equations. The main kinematics equation that we tend to use in solving our problem are v equals to v naught plus at. Now remember, this equation does not depend on the final distance or initial distance. So if your problem does not have a distance, one can use this equation. Second equation, x equals to x naught plus v naught t plus 1/2 at squared. Now this equation does not depend on the final velocity. So if you're solving a problem that does not give you any final velocity, you don't actually have to find the final velocity. One can use directly this equation to find the required quantities. Third equation, v squared equals to v naught squared plus 2a times x minus x naught. Now this equation does not depend on time. So in your problem, if time is not provided, one can use this equation in order to find the required quantities. Now remember, more than 2 quantities might not be given. So you may have to individually select the appropriate equation. If there are 2 unknowns that one is required to find, then you must use two equations. Remember, the number of unknowns equals to the number of equations that you must use. So, I hope this helps in selecting your kinematics equation, and I hope this lecture will be helpful. Thank you for participating in this video. I really appreciate you guys for being here and helping this channel. Please subscribe if you haven't done so and come back later on for more videos. Thank you.